Alright, here's my favorite bed and layer adhesion test. So there's other types of layer adhesion tests where you print a really thin squares around and so forth. But this test has worked great for me. I invented it, so that's why I like it. That's why I have my logo on it. This again is an open SCAD project. It's on Thingiverse, and I have a link to this in the show notes, so you can change it the way you want. Put your own text in here if you want. But this tests a number of things. One is the bed adhesion. So this is not a huge square, but big enough to get a good test of whether all the corners are sticking to the bed and things like that, whether your bed temperature is set correctly. And then also tests your resolution on printing. So printing this embossed lettering here tests whether your cooling's working. If you don't have good cooling, then you get blobby letters here. They don't have a good definition. And then your layers here. So this is kind of an overhang here, so you're testing to see how well your cooling is working when you're printing these engraved letters. But the main purpose of this test is to check the layer adhesion. I mean, the bed adhesion is important, but the second most important thing is layer adhesion. If you don't have good layer adhesion, then your models will be brittle and start cracking, as you might see, again, coming attractions. So this joint here is very susceptible to poor layer adhesion, because you can pull on these corners here toward each other, and if this joint is strong, it'll resist that force. Now, if it's weak, then it's going to crack. So, again, we'll check that out. So, this is the filament. We've printed the black version, probably at least 10 rolls of it with no problems. Easily passed this test. We'll see what happens when we do it this time. All right, so let's put this in Simplify 3D, and we'll slice it and send it over to the printer. All right, so here's our bed and layer adhesion test in the Simplify 3D. Again, we're using the NX here. I don't think I mentioned that. The Guider 2, I'm printing some other stuff now, so I'm working on a new product that I want to use this gray PETG for, and I can do prototyping. This bed surfaces and volume here is big enough for prototyping, actually for production if I want to. All the parts will fit on here. So while I'm printing my stuff I'm already selling on the Guider 2, I can just do my prototyping here as I can go along during the day and make some more progress on that and not interfere with my regular production. Okay, so based on our temperature tests, we liked our extruder temperature of 237. The other temperatures printed okay too, but that temperature printed fine, and it's easier to keep all PETGs at the same temperature. It's simpler when you're doing production because then you have your preheat always set to the same thing, so you don't have to think about it. PLA prints at a lower temperature. You got to know I'm printing PLA, so I use this preheat temperatures, and PETG uses a different set of temperatures. And our layer adhesion is good. Our bed adhesion is good with 65, so I'm going to use that. Now for cooling, this actually reflects the fact that the first test with 10% didn't work. So you'll see that coming up. So I tried 5% here, and we'll see what happens with that. And again, for PETG, you want some cooling, at least I do. And 5% is the lowest I've gone. So we'll see what happens with that. Everything else is pretty standard. We're using 0.2 layer height. We are printing a number of projects in PETG with 0.3 millimeters to speed them up, some bigger items, and having good luck with that, with both Sunlu and Hatchbox. So I guess I haven't really printed that much California Filaments at 0.3 layer height. We'll have to see how that works out. So. All right, and our extrusion multiplier for PETG is 1.0. We have a 0.4 nozzle diameter. I'm mostly using auto here, and the auto default that Simplify 3D says you should use is 0.48 millimeter. That speeds things up. Some we have small details. You can set this manually. And actually, usually I set this higher to prevent stringing. So usually for PETG, I set this higher. I'm not sure I didn't do that. So for PLA, 1200 millimeters per minute is good retraction speed for me anyway. For PETG, it's more likely to string in my experience, so I increase this a little bit, and that seems to prevent prevent stringing. So, all right, so we'll send this over to the printer and see what happens. Again, the first time we're going to try is a 10% fan, and that has a problem, and we'll try 25%. We'll see what happens with that. So we say prepare to print. It slices it, and then it's going to take 54 minutes and about 10 grams. Now I found Simplified 3D version 4 overestimates the amount of material you need by about 10%. But this is a good conservative number to make sure you have enough on your reel. So send it to the printer and see what happens.
Alright, let's check out the results. So we have a little string at the end here. That's pretty standard. Get it off the print head. Alright, we'll get rid of our white loop, comes right off. And we'll flex. Comes right off. Alright, so this is pointed at point 2. So the detailing on the engraved letters is pretty good because we only have 0.2 millimeter layers. Bottom is super clean, so our bed temperature is perfect. With the NX, because this sticker here is thicker than the one on the Guider 2, I have to go to 65 degrees here to get to around 50, a little over 50 degrees at this bed temperature. You can saw that when in the review that I did this one. So the review of this print surface. This back on there. All right, so the main thing is the strength. Ooh, not good strength. Well, that's not very good. I'll have to see what happened with that. Huh. That's not good at all. So we'll have to work on that some more. Obviously, that's why we test. Could be the cooling is too high. Could try 5% cooling instead of 10%. All right, so that's why we test. All right, day 2 of testing our California Filaments Gray PETG. So these are our failures from yesterday as far as the layer adhesion test. I just wanted to show some other ones I've printed. Like here's Overture PETG with similar parameters, and it's super strong. Here's another one, Overture. This is JO PETG. This is black, and I'm not sure if I didn't find the black California Filaments test I did for this. It's just around there somewhere. But here's some of the ones I've done recently. Sunlu. This is at 0.3 millimeters layer height. So this test should work. We're gonna get it to work one way or the other. If we can't get it to work with this gray California Filaments, we'll try Sunlu, because I mean eventually I'm probably going to switch to Sunlu because it's cheaper and it seems to pair well. This is Yoya. That's an older one I had. So I do have some chunkier pieces that don't require this level of strength that I can print, that I need to print and engrave for my new project. So I will be able to use this up, which is good. I hate to waste filament. So I thought about what to change to try to get it to work. So one idea I had was to lower the temperature. That's something I haven't really tried before to improve layer adhesion. I assumed that a higher temperature would have better layer adhesion because it's more fluid, so it would stick together better. But that may not be true. So we're going to test that possibly, because this printed fine at 233, and I printed some other. I printed some Sunlu filament that was white. It seemed to print better at 233. I haven't decided what temperature I'm going to use on that yet. But so that was one idea. The idea was to go to maybe 1% fan or 0% fan. But what I decided to do was use the black California Filament Oh, one thing I wanted to point out about the temperature. So this says it'll print down to 230. So possibly lowering the temperature might work. I'm going to try that probably at some point. But a better test I thought to start with was to take the black California Filaments PETG that I've printed at least 10 rolls of this with no problem with these kind of parameters. I'm going to try the same test, the Bed and Layer Adhesion test that failed for the gray. We'll try one the black again just to make sure there's nothing strange about my NX setup, because I haven't been using the NX that much lately because I got the Guider 2, but you know, I've got 100 videos on this printer, including these kind of tests that if you look at my old videos, you'll see these. So I'm going to try this black PETG. I have enough left on this remnant reel here to do this test. So that's the simplest thing we can do to see if there's something else we're missing as far as what's going wrong. So if this works, then we definitely need to adjust the parameters to make this work. And like I said, if I can't get this particular test to work, I can use this filament up, which is good. All right, it's done. This is our PETG Black California Filaments with the 5% fan and layer height of 0.2 millimeters like we did with the gray. So we're going to take a look at this. Pops right off. We're going to let it cool just for a second and look at it without flexing it. So bottom looks perfect. Lettering looks really good. Come back here. So yeah, a little bit of stringing on this B here. I don't know if you can see that. Let's try flexing it now. All right, so this is strong. See that? All right, so there's something weird, something different, let's just say, about this gray PETG from California Filaments than the black. So I had so much good luck with this, I just assumed, which is a dumb idea, obviously, this would behave similarly, but it doesn't. It has a different additive for a different color. So, all right, so we're going to try a couple different more changes with this. The first thing we're going to try, keep it on 5% fan and try printing at 233. Have we ever tried that before for layer adhesion problems? So see if that makes any difference. If that doesn't work, I might try 0 fan. And if that doesn't work, then like I said, we have some chunky things we can print with this, and I'm going to switch to Sunlu. So I'll go ahead and print this out. This gray version. I'll print it out in gray with a 233 degree extruder and 5% fan. All right, it's done. Get our string off. Drip down on our problem there. All right, looks pretty good. Proof is in the flexing. Okay, I'm going to let it cool a minute before we try to torque it. So, again, lettering looks about the same. Layer adhesion, super nice, or bed adhesion. These letters look good. So 233, it printed pretty well. Let's see how strong it is. Hey. All right, well, we just learned something. Printing at a lower temperature, as long as it's high enough, can increase your layer adhesion. All right, well, that's strong enough to print to work with. So we'll just have to set this at 237 or 233 when we're printing it. That's not a big deal in Simplify 3D. We can still use our preheat temperature of 237 in case we forget. That's fine, but then as it actually starts printing, it'll go to 233. So you see that flexing there? That's a strong joint. So that's good layer adhesion. So that's a thumbs up. Thumbs up for California Filaments Gray. It just was a little harder to figure out than normal because it didn't print the same as black. So okay, so we learned that. All right, so now we're going to do our fun print and see how that turns out.
All right, here's our fun print for this PETG. I haven't printed this in a long time. I think I printed PETG once a long time ago. So we're going to be printing some smaller details of this filament. So we wanted to test something fun that we can compare with other previous tests we've done. So this tests a lot of things: small circles, some overhangs, and this twisting tower of a double helix tower, and so forth, and a little spire at the top. So it tests all sorts of different things about your filament. It also does some cutouts here on the bottom, and some here's some more overhangs. It tests your bridging over here. So this is kind of a torture test, you might say, for filaments. I've used it a few times. It takes a little bit longer than some of my other tests, my other fun tests, so I don't use it that often, but I thought this time would be a good thing to really wring out this filament, make sure we got everything dialed in as far as extruder temperature and cooling. So this prints like this. It takes about 1 hour and 45 minutes. Again, we're printing this at 0.2mm layer height. And actually, this is another thing I usually change. Usually 50% speed on the first layer is fine for bed adhesion for me. And I squished the first layer a little bit, 90%, so let's update this. Yeah, so we have 3 solid top layers, 3 solid bottom layers. That gives you good coverage, and then 2 shells on the outside. So anyway, we'll send this to the printer, and we'll see how it turns out, and whether we can use this filament for our product.
All right, let's check out our PolyPearl Tower. The string off. Looks like it came out great. Let's get this off. Let's try our flexing. Space is really thin, so it might be hard to flex it off. There we go. Some residual on here we can get off. This edge is super thin. I think it's only 1 layer thick, so that's probably part of the test. We're going to heat that up and I'll get it off later. Alright, so the base looks good except for that raggedy edge a little bit. So, I don't usually print things at 1 layer. They don't usually work out so great, as you can tell. But everything else looks pretty good. Let's see, there's some stringing, minor stringing up here. It's not too bad. Here's the overhang. Overhang printed. Oh, we can't see it, sorry. There's the overhang, like the entrance, and printed well. The bridging looks okay. These little thin towers in the middle, the 3 tiny ones, look good. These big supports here look great. This ball looks really well done. Spiral looks good. Come up to the top. The spire looks good. There's a little bit of blobbing on the end here, but it's not too bad. Here's what I did a long time ago. I didn't write what filament this is. I think this is a PLA. It's a sparkly silver PLA. See, it has some of the same issues, some stringing, a little bit of blobbing on the top. We could try, I'm going to try printing my actual product next, but I may try increasing the cooling temperature back up to 10%, or the cooling fan speed to 10%. Maybe if I notice some blobbing, I'm going to try that. So, but in general, I think this is a good filament for us to use. Oh yeah, this is strong, plenty strong here. Lots of layer strength now. Printing at 230. Just those 4 degrees of difference in temperature made a huge difference, which is interesting. Which is good, actually. I mean, now we can use this filament. I'm still probably in the long run going to go with Sunlu because it's cheaper. Sunlu has gray as well, and it's 20% cheaper than California Filaments, at least unless you buy 10 at a time, which I don't have that much production. So, in any case, thumbs up after a little bit back and forth, more than normal on setting up parameters for California Filaments Gray PETG.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.